Hello students, we're going to start with video 2.2. Remember the unit title is Logic Lines, and again the objective is the same because we are now working on algebra and geometry, but I do want to add in one more, and that is that I can create a two-column proof. Okay, so I can create a two-column proof. So your Excel skills for this week are only C6. Now this is a proof skill, so it will take some time, so please make sure you plan it out and get it done. All right, so let's go flippers. So right now you're looking at a properties of equality table, and we actually saw this in class on Friday, but what I want to do is I want to go through it really quickly with you and just make sure that we have examples for everything. Now Samantha and Amy provided us with really good, clear examples, but I want to make sure we all have them written down for addition properties, subtraction, multiplication, and division. We actually were able to apply these. And remember, these are properties of equality, very important, which means they all have an equal sign. In addition to those, there also are reflexive, symmetric, and transitive property. And then finally, substitution. This is the one we didn't really actually use in class, but an example of substitution would be if I had 3 times 4, and I know that that's 12, the next time I have this in a problem, I wouldn't write 3 times 4, I just actually write 12. So it's when you actually substitute a value in that you know that actually works. The next set of properties are properties of congruence, and we actually talked about these as well. And those are reflexive, symmetric, and transitive. And I feel like it'd be nice if we saw an example. So what I want you to do on your paper is I want you to make these 3 triangles, triangle ABR, triangle FEG, and triangle CDT. Okay? And we're going to follow along with this. It says the reflexive property AB equals AB. So clearly we can see here AB does equal AB, and more or less angle A equals itself. So it's kind of like a mirror image. If you look at yourself, you're going to have yourself. The next one is going to be symmetric property. Well, symmetric property states that if AB equals CD, and here AB is going to equal CD, so let's make it happen, then CD equals AB. And that should be pretty straightforward. And that, again, involves 2 specific things. Two things, whereas reflexive involved 1. Okay? It also states that angle A equals angle B, then angle B equals angle A. All right, so let's move on to the transitive property here, which talks about 3 different things. It focuses on line segment AB, line segment CD, and line segment EF. And it states that if AB is congruent to CD, then CD is congruent to EF. Therefore, AB is congruent to EF. So that's 3 direct connections to each other. It also can tie in angle measurement. Angle A being congruent to angle B being congruent to angle C. Let's add that in. Then that must mean that A also equals C. And that's what we have. Remember, all of these properties of congruence will involve congruency marks because they're talking about defined space. These problems have been leading us up to start what we call proofs. So here we have 2 definitions. First one is going to be a proof. A proof is a convincing argument that uses deductive reasoning. So let's start with our first proof. 1 plus 2 equals 3. Well, how do you prove that? Well, my son's in 1st grade, and he has to prove this, so he has to sometimes draw one little box or circle, and then he has to put 2 more over here, and then he has to put on the other side, he makes a line, he'll put 3. Then he'll say, well, Mom, you know what? I have 3 things over here and 3 things over here, and these are equal, so now I proved it. And I say, hooray, you're right. Well, we use something called a 2-column proof. And a 2-column proof is going to be a special kind of proof that lists statements on the left and reasons on the right. So let's do the same proof again as a 2-column proof. So here we are doing our first 2-column proof, and what we have to prove is that 1 plus 2 equals 3. Our given here is, well, we don't really have any givens other than all the things we know about the number system. Statements are going to go on the left, and reasons are going on the right. And we're going to number them as we go. So let's begin. So let's just backtrack for a second here. A given is that 1 is being added to 2. So we do want to write that down. We want to say the reason is because it's being given to us. It's told to us. So now we want to say what we do actually know. Well, we know that 1 plus 2 is equal to 3. And the reason why we know that is because 1 plus 2 is 3. So that means 3 actually equals 3. Now the reason for option 2 is because we are going to use just properties of addition. And that's just simple addition. Now what we want to do is we want to say, well, 3 equals 3. Well, that we've now gone ahead and substituted in 3 for 1 plus 2. And this is true because we just talked about it. This is the reflexive property. 3 equals itself. So this is reflexive prop of equality. All right. So what we also want to do is we want to recognize that these two-column proofs can now be used to do all types of proofs in geometry. Here's an example problem of what a proof in geometry looks like. Another one. Here is a given, clearly, and what they want you to prove. Statements on the left, reasons on the right. There are no reasons here, but again, each statement has a reason that correlates to it. And at the end, you always want to write what you are trying to prove. And you're trying to prove that this here statement is true, so that's what should be at the bottom, along with the reason that goes with it. Let's try some examples. Our first example, it says, write a two-column proof. Here's the given, here's what we have to prove. I've written down the statement and the reason, S and R. That's my shorthand for statements and reasons. Number 1. So number 2, what's going to be the first thing we do here to solve the problem? Well, I think we're going to distribute. And that's exactly right. So we distributed it. Now, what do we do next? So now, clearly, to eliminate that 4/9 from both sides here, I subtracted 4/9 from both sides and ended up with 2 over 9x equals 15 over 9. So that was subtraction property of equality. Our next step, so my last step here is to go ahead and say, well, I want to actually get x to equal 7. And how do I do that? In order to get 2/9 away from x, I actually divide both sides by 2 over 9. And then we're getting x equals 7. And that is division property of equality. And look, what I wanted to prove was my last statement, and I did it. All right, so let's try another example. Okay, so the first statement that we want to write down is what's given, and that is that the measure of angle 1 equals the measure of angle 3. So if we look at our picture here, they're saying that this angle is the same as this angle. And the goal is to figure out the angle AEC is equivalent to angle DEB. That's what we're trying to prove. So we want to add in the second step here, which is that the measure of angle 2 equals the measure of angle 2. And that's true because of the reflexive property of equality. So again, now we're trying to get to include AEC is equal to DEB. So our next step would be, so here we have step 3, which says, hey, well, now we've got the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. So imagine that we just basically added angle 1 to one side of this equation and added angle 3 to the one side of this equation. And we can do that because of the addition property of equality. Well, now our next step is going to say that, well, the measure of angle 1 plus 2 is really equal to AEC. And that's true because those are actually now using letters to state the angle. And the same thing for the measure of angle 3 plus angle 2. That really is DEB. And that's going to be true because of something we used before called the angle addition postulate. And that just states that if you have two angles and you add them together, that they equal the larger angle. The final statement here is the one we wanted, and that's what we wanted to prove, which is that the measure of angle AEC is equal to the measure of angle DEB. And the reason for that is because of the substitution property. Because now we're just basically substituting in what we want. And we're done. Okay, so here's your secret hot question. It says, justify with a reason how to go from line 1 to line 2. So this is line 1, and this is line 2. So what is the reason why this is okay? What property allows it to work? And remember to do your IXL. Remember, 15 minutes for your video and then 15 minutes for this IXL skill. If you do that every day, you will get things done on time. See you in class tomorrow.